And the next, I gave another handout, and it talks about the presentation today from Mark Gage from Guardian Safety. Also gives a harness inspection guideline that you can use on the job. If you guys, I can send this in a PDF if you want. All you got to do is email me and I'll send it to you. Okay, but this is a good a checklist on the harness, and we're going to talk about that today. So thanks a lot. Thank you very much for coming. Everyone should have a raffle ticket. At the end of today, we'll give away some gift cards. Everyone should also receive a T-shirt for attending today's class. So appreciate y'all. I'm going to give it over here to Mark Gaines. He's from Guardian Safety. Yeah. Thanks, Mark.
Thank you. All right, good afternoon, guys. I'm with Guardian Fall Protection, and it is all about safety. So we're just going to kind of talk about Fall Protection Awareness 101. This is the training that we do for end users, from commercial to construction to general industry. So, you know, there's two fall protection standards out there. One for general industry, the OSHA 1910, and then there's one for construction, 1926. And they both mirror each other pretty well. As Ray was saying, falls, injuries and fatalities from falls are probably about 30 to 35, 40% of the construction industry, just because of the nature of your work or when you're working at height. And today, most of our equipment with technology and the software we have, like on sewing machines now, all the harnesses are stitched very well. You don't run into missing stitches and are missing complete web and straps being stitched together like we used to back in years past. A lot of the retractables today, the SRLs, some of them, like these red ones you see up here, are actually put together by machines and have software programs that measure the torque value when we cinch down the fasteners in there. So the technology has really helped us in making quality product, and most of the injuries occur when workers aren't doing the proper inspections, or if your harness isn't cinched up properly or not the right size harness. We can rip skin, have internal injuries, and things like that. So we'll talk about suspended trauma and a rescue plan. That's very important. We'll talk about inspecting equipment. We'll talk about tie-off points, how to calculate the proper clearance for different devices such as a 6-foot lanyard versus a retractable SRL. So we want to make sure that we understand the different clearances required, because each device up here may require a different clearance to be safe. So let's talk about a fall protection plan and rescue. Every company has a fall protection plan, right? They assess their hazards and then select the equipment based on that hazard. Part of that fall protection plan is supposed to include a rescue plan. So if I ask a question, if somebody falls and you're suspended in midair, what is your plan to get them down to effect a rescue? You guys have one? This is a very common answer. I bet you 99.9% of the time I ask that question, I get the same response. And for whatever reason, rescue plans seem to get overlooked. Why is it important? Have you heard about suspension trauma syndrome? So here's what happens when we fall on a harness. The harness is going to want to ride up on the body, right? This back dorsal D-ring right here, this is going to slide a foot and a half over your head at a minimum. So you want to remember that, because we got to add that foot and a half when we're calculating our fall clearances. You're going to add that foot and a half in. But the weapon's also going to cinch up on the body. It's going to tighten up. And we have a main artery in our leg, right? And this leg strap tightens up and cuts off the blood circulation. So, you know, our heart pumps blood out. Muscles contract back and forth, and that creates blood circulation. Well, if you cut off the blood circulation, you might have gravity take effect and blood starts traveling downhill, so organs can become devoid of blood. Here's an issue. If you have blood traveling down, you could have pooling of blood in the legs. Now you could have blood clots. If blood's not filtering through the liver, because of, loss of blood circulation, you can build up toxins in the bloodstream. So there's another set of issues that can arise. So being suspended in midair is not really a good thing. Unfortunately, we've had persons fall, have no injuries, and pass away within 20 minutes just being suspended in midair. So that's pretty scary, isn't it? Every individual is different. We've had young guys that are healthy and good physical condition that have hung there for 2, 3, 4 hours, and it didn't have any ill effects. But we've had other guys, unfortunately, pass away within 20 minutes. So the whole point about the rescue is have a little bit of plan before you climb and go to work. So I understand you guys are using lifts and maybe scissor lifts, JLGs, things like that. That's a good way to rescue somebody, depending if you can get up to the height that affect that rescue. But just have a little discussion amongst yourselves and have a ladder stage nearby, that lift or a ladder. If somebody does fall and they're suspended in midair, if we can get something underneath them that they can stand on and relieve that pressure against that artery, that's what we're trying to do. So if you look on these harnesses, and I believe you guys have Guardian harnesses, is that correct? Do any of you have the suspension trauma straps on your harnesses? So what this is, there's a strap on each side, and I'll show you how it works.
If they do, some of them are they attached or added on features.
Right, so we got some high-end harnesses comes as a feature, but most of the time you're going to buy these and add them to the harness. It's not a very expensive system. It's also not regulated or mandated by OSHA, so they don't require it. This is more of a best practice. But this can buy that guy some time that's suspended in midair. So the Guardian style is kind of like a cargo strap, and I like ours because I can adjust this to my height. And once I have it adjusted to my height, I can roll it back up, put it in the pouch, and then if I fall, it's set and ready to go for my height. A lot of the competitors' products don't give you that option, and you got to figure it out after the fall. But what this does is, I got a strap on one side, a smaller strap on the other side, we connect them up. And you guys in the back that can't see this, you might want to stand up and just take a quick look at this. But the belly of that strap, you want it to be between the knees and the ankle. You don't want it touching the ground. And if it's in between the knees and ankles, what I'm going to do is, after the fall, I am going to step in it and straighten my legs out. And you notice it's already pulling these leg straps down, relieving that pressure up against that artery. So that allows the blood to start flowing again. So that's how these work. If the guy hit his head on the way down, he's unconscious, these obviously aren't going to do him any good, but he's really going to be dependent on his co-workers to help effect the rescue as quickly as possible. So it's really important just to have that plan, have a brief discussion, and before you climb and go to work. And I have a set of these for you, Ray, on the table here. I'll give you before I leave, so you can show the guys if you want. One other thing, if you talk to doctors and nurses, they say we got to get you down in 5, 6, 7 minutes, because that suspension trauma syndrome can start kicking in pretty quickly. I've talked to guys suspended in midair, and they said their lower half has gone numb in about 5 to 6, 7 minutes, so that's pretty quick. OSHA says we got to effect a rescue promptly within 15 minutes. In the real world, it's not always going to be doable, right? So try to have a little plan and have that discussion, have something nearby that might assist you in rescuing somebody. Now, if they're hanging 90 feet up in the air, suspended in midair, that rescue might be a little bit more complicated. You may not get them down that quickly. That's why these things are a good idea to have as well. If you effect a rescue, let's say somebody's hanging there for any longer, 5 or 6 minutes, like I said, let's call 911, have paramedics on the way. They can address those medical issues. But if you get the individual down prior to the first responders get there, you want to, you get them down, put them in a sitting position with their knees tucked up a little bit until they've been evaluated and released by that medical professional or that EMS guy. If they develop any blood clots and we lay them out on a cot, or if we stand them up straight, that blood clot could break free, erase the brain, heart, or lungs, and kill somebody. So keep them in a sitting position until they've been evaluated by a medical professional. Any questions on that, guys?
The one you have on there, is that an attachment or is that the one that comes?
Yeah, so this is the Guardian version, and this is just cinched on the lower pelvic leg straps down here. You got to make sure you put it on the leg straps, so if you use it, it's pulling down on those leg straps. We've had some guys put them on the torso strap up here, and it doesn't really work that way, so you just got to make sure you get them installed correctly. All right, so have a little plan before you go to work at height. Tie-off points, what we tie off to, sometimes that's one of the harder things for us to determine. OSHA says whatever we tie off to has to withstand 2 times the load we generate on a fall. On that Guardian band out there, I've got a boom in the back end. So when we get done with this presentation, I'll go set it up real quick. I got a 220-pound weight, and we'll do a couple drops with it. The initial drop, we'll use a restraint lanyard with no shock absorber on it, and we'll get the true measurement of the force we generate. And then we'll do a drop with a shock absorbing lanyard and then a retractable. But if our tie-off point has to withstand 2 times the load we generate on the fall, that 220-pound weight just dropped at 4 feet, we can generate about 3,600 pounds of force. That's pretty significant. We have had guys fall off their feet, hit their head hard enough and kill themselves, right? Because of the impact on that fall. So a sharp free fall can generate a lot of force and energy. Why 220-pound weight? That's about the average weight of a worker, okay? So, the maximum resting force, that's the maximum amount of force we can apply to the body is 1,800 pounds per OSHA. If you exceed more than 1,800 pounds of force to the body, you might start ripping skin, internal injuries, things like that. If our tie-off point has to be 2 times the load we generate in the fall, we're going to use that maximum resting force of 1,800 pounds, times it by 2, and come up with 3,600 pounds. We can literally, technically, we can tie off to a 3,600-pound low-rated anchor point. But in order to do so, you have to have a structural engineer come in and certify that anchor point that it will truly hold that static load of 3,600 pounds. And they charge a nice little fee to do that. And I would imagine that in the work you guys do, there's probably hundreds of areas where you got a tie-off point or where you can tie off to. And you're not going to have each one of those locations certified. It's just too expensive. Same thing in general industry, construction. Obviously, there's probably not even an anchor point until we install one. So, that 3,600-pound anchor point's only if you have a structural engineer certified. So if we don't have a 3,600-pound certified anchor point, we're operating on a 5,000-pound low-rated anchor point, and that's considered uncertified, okay? Somebody from the company is supposed to be able to prove that tie-off point for you, but we're supposed to be technically tying off to an anchor point that will hold a static load of 5,000 pounds. Now, a lot of times you can get those load ratings from drawings, blueprints, things like that, or an engineer on site, but if you can't achieve that, we know most guys, you know, they got to make a living and they're going to go to work, and if they're told they got to work at height, even if they can't get that confirmed 5,000-pound load rating, they may tie off anyway, right? We know how guys are. So if you're going to tie off to something, and fall protection guys have been teaching this for years. It's not technical, it's not very sophisticated, but imagine stringing up a pickup truck to an I-beam structure, or some kind of structure that would hold the load of that pickup truck, about 6,500 pounds. We've had guys tied off into electrical conduit, PVC water pipe, 2x4s nailed up against the wall, and I'm sorry, but that's not going to hold you in the event of a fall. So if you can visualize a structure that would hold that load, the weight of that pickup truck, it's going to hold you in the event of a fall. Okay? Whatever you tie off to, that tie-off point has to be on something that's got some beef, some structure. So just kind of visualize, hey, would it hold the weight of a pickup truck? Okay? Like I said, I know it's not sophisticated, but it's a way to get you guys to visualize that anchor point and if it's going to hold you in the fall. Technically, you're supposed to have somebody competent appointed by the ownership to approve that tie-off. Just to give you a little peace of mind, on our lanyards and our retractable, this is a dual leg lanyard right here. It's a twin leg for 100% tie off. But it tells you right here on this label, it tells you this is going to allow a 6-foot free fall. And it says it will reduce those forces on the body down to 900 pounds. So that's half of the maximum resting force, okay? So when you fall, you're not generating that 3,600 pounds or that 5,000 pound of load. You're actually going to, when the shock pad deploys, it's going to reduce that energy. So you would be putting only 900 pounds on that structure or that anchor point, okay? Once we've established our structure, load ratings, we have different anchor points. You guys have probably seen the IV makers. What are some of the common anchors you guys use? IV makers? D-rings? Any cross arm straps? So a couple things about IV makers. We have a couple different types. This one's a floater. So if I have an IV, obviously we can adjust these to the width and the flange thickness, but this floats on the IV, so I can travel with it. It allows me a larger work area. We like that. Having the traveling anchor point also helps eliminate that pendulum effect a little bit, that swing fall. So my anchor point's right up above my head, and I end up falling on and kind of bounce up and down below my anchor point. But if I'm more than 3 or 4 feet out of line from that anchor point, you're going to create that pendulum effect. So now think about the force we generate on a fall. And then think about that pendulum effect on an edge that you go over if you fall and create a cutting action. We've had steel cable cut in half because of swing fall and the forces we generate on a fall. So we'll talk more about leading edge and preventing that kind of an issue. But a traveling anchor point is going to help reduce some of that pendulum effect, okay? Does that make sense, guys? We also have IV makers that will lock into a fixed position. The ones that lock in a fixed position we could use on a vertical column. Now we wouldn't want to use this floater on a vertical column because it's just going to shimmy down, right? Point is, if you're going to use an IV maker, you want to make sure you know which one you're grabbing and you're using the right one for the application in here. You can also take a cross-arm strap and wrap around an IV. These come in various lengths. We can wrap around pipe racks, I-beams, wood joists, whatever you may have. Technically, it should hold a 5,000-pound load, right? This black webbing right here is Dyneema. We make cut-resistant sleeves and gloves out of it, but that gives you a little extra protection on those edges. So these come with or without that Dyneema strip on there. I always recommend the premium straps because that gives you that added protection and cut-resistant. Abrasion resistant. So this will last a little longer, plus it gives you protection up against that edge. If you're not comfortable with that, we do have steel wire rope. And in some cases, we can put like a PVC coating on it. So if you're up against, say, a stainless steel vessel you don't want to mar up or scratch up, you might want to use a cable that has a coating on it. Sticking with the I-beams, I don't know if you guys have seen this bolt hole anchor. But if you got a bolt hole right there, I can insert this, release it, and I've got a 5,000-pound rated anchor point right here. I can use it horizontally or vertically. You can even run a cable in between. By the way, all these anchor points have a worker weight capacity of 310 pounds. Now we do have some that go up to the higher worker weight capacity of 420, but the majority are 310 pounds. That includes your tools and your clothing, okay? You know, I want to back up a little bit. That 3,600-pound rated anchor point that's certified by a structural engineer, all of our snap hooks, the gates, rebar hooks, and even our carabiners, these gates also have a load rating of 3,600 pounds. It is stamped on the gate 3,600 pounds. And the reason why that's important to understand, they changed that standard back in 2015. And prior to that, we had snap hooks that looked like this. So if you look at the compliant snap hook in my left hand, and then you look at this little flimsy hook in my right hand, This gate only had about a 325-pound load rating on the side, 220 pounds on the front load. And what would happen if a guy were to fall, let's say his anchor point was below the waist, sometimes what could happen is that D-ring, the tie-off point, would cross over that gate, and on these old flimsy hooks, gates, would pop it right open, and that's what we call forced rollout. And we had guys hitting the ground. I took this out of service, about 12 of these out of service just about 3 months ago. They're still floating around out there, but if you don't see 3,600 pounds stamped on the gates on your snap hooks, carabiners, and our rebar hooks, they are no longer approved for fall protection. Just want to make you aware of that because, like I said, I just pulled this out of service. They're still floating around out there.
Yeah, we'll get them replaced if you got any of those on your job.
So on the anchor points, I don't do any residential stuff. So we have residential anchor points. Now on residential anchor points, some of them have a limitation. You ever seen a timber anchor?
Yep.
So, you know, it's got multiple holes in there, and there's multiple holes in there because that's how many we have to use. We have a lot of guys that just throw a couple on one end and the other end call it a day. That's not going to hold you. You got to follow the instructions, right? And do it properly per the instruction from the manufacturer. But if I were to fall using this particular anchor point, I want the load to be applied to the ends of these anchors. That way you have the full support of all the fasteners on this entire anchor. If you have it where you're falling and putting a load on the side, this can rip right up out of the substrate. So in this anchor point, it's recommended to keep the load on the end and working within a 35, maybe 40-degree radius from your anchor point. Again, not all anchors have a limitation. Most of them, like the bull anchor right here, I can fall in a 360-degree circle. Same thing here, I can fall in any direction. Just be aware some anchors may have a limitation, and specifically if they're designed for wood structures, you really want to understand that anchor point. I would encourage you guys to read the instruction manual for all fall protection equipment. Lanyard, SRLs, harnesses, anchor points. Unlike our traditional PPE, if I forget my cut-resistant gloves and I cut my hand, I know that will heal in a couple days. If I screw up on my fall protection PPE, I might hit the ground and you may not ever get up again. So you really want to take the time with fall protection PPE and understand it. We also have specialty anchors. We have an engineering department. We can do engineering anchor points and design complete systems. So any questions on anchor points? There's no questions there. Let's talk about our inspection process on our equipment. So we're going to walk through the harness real quick. Because like I said, we have a lot of the injuries or fatalities when it comes to doing the investigation. In many instances, it's the equipment failed because proper inspections weren't done and the harness failed, or the harness might have been too big for the individual, or maybe not cinched up properly. So we're going to talk about how to inspect this, how to measure for the right size harness, and how to cinch it up properly. And then we'll talk about the different types of harnesses. All right. So we're going to start with a basic harness. So our basic harness is probably what everybody's familiar with. To some extent, there's no padding on the shoulders, there's no padding on the legs. Usually a basic harness is going to have the pass-through chest connector, but you got the front torso straps, you got the back torso straps. You're going to have a sub-pelvic strap, or some guys call it a butt strap, but if you think about it, when you fall, most of the load's going to go in the lower half of the harness, so you have these sub-pelvic straps now that were, I guess back in 2015, they created the standard to make sure harnesses have these. Any of the older harnesses that don't have that, you can still use them. They're grandfathered in. But all the new harnesses will have this self-pellet strip.
Hey, Mark, when does a harness go out of warranty?
So, on warranty and things like that, we have the traditional workmanship warranties for a year, right? But as far as how long do harnesses last, it used to be we had a 5-year shelf life on all this equipment. And when it got to that expiration date, regardless of the condition, if it was good or bad, you had to get rid of it. And that was unreasonable. It just causing people to have and to buy new equipment when the existing equipment was fine. So now, we can keep this as long as it passes an annual competent person inspection, okay? So, speaking of inspections, you know, we have a competent person, we have authorized users, we have qualified people. A qualified person in fall protection is somebody by extensive experience or degree can design and implement a complete fall protection program. A competent person is really kind of your go-to fall protection guy, but he's going to be required to do 16 hours of training and be certified for 2 years, and you have to redo that certification every 2 years. But he's the guy that's going to say, hey, this is the equipment we need for this job. If he sees a hazard that you don't have the proper equipment, he can shut the job down. If he sees an employee misusing a piece of equipment, he can require you to do additional training immediately. Okay, so he's really your go-to guy in fall protection.
That'd be me.
Yeah, that would be you. And then the authorized users are you guys. So you're hired to work at height, right? And it's really, you guys want to have a good understanding how this works, right? Because it's going to affect you more than anything. And we want to get home to our families every night. So, both standards in general industry and construction, 1910 and 1921, both require inspection prior to use. So that means every time you put this harness on, you got to inspect it. Same thing for your 6-foot lanyard, your retractable device, and technically your anchor points. A lot of times the anchor points are up there and you can't really inspect it until you get up to it. But there are some gray areas when it comes to fall protection. When we inspect this, let's start at the top. Let's not start in the middle. You might get distracted and not inspect the entire harness. And listen, if you fall, you're going to generate some forces, and you don't want any areas to fail, right? So if we start at the top, on the back side of the harness, on the back dorsal straps, you see these tags right here? You have a piece of the webbing, it's folded together, and a couple stitches popped in there. Everybody see that? Those are impact indicators. So that's your visual clue. Look at those first. If you notice this tag's ripped open, this stitching's been ripped open, it's been impacted in a fall somehow. Or some guys have figured that this will wrap around a small engine block and they can lift that engine up. But at about 450 pounds, you're going to pop these indicators. Okay? So if you notice that's popped, there's no sense of inspecting the rest of the harness because we're going to fail it at that point. Soft goods, meaning anything made with webbing, we're going to document it, part number, serial number, the date it was manufactured. We're going to fail it, and then we're going to cut it up and destroy it. If I throw this in a trash can without cutting it up and somebody comes and grabs it, uses it, gets hurt, they can hold you liable for that. So, again, on soft goods, even our retractables, this is considered soft goods because it's a webbing, right? If it's steel cable, that's different. On retractables, 20 foot and less in length, usually it's not worth sending in to be repaired if it's a steel cable. But the larger SROs are a lot more expensive. They can be repaired and recertified. So when we look at our harness, impact indicators are in good shape. Then we're going to move right down to the label. The label must be present and it must be legible. If I pull this out of the package brand new and for some reason the label's not on there, I have to cut it up and destroy it. You can't use it because you can't document it and it has valuable information in here. Now I know it sounds unreasonable, but the reasons why is because we don't carry instruction manuals with us, and that vital information's in here. An example, worker weight capacity. The OSHA standard for the worker weight capacity calls out 310 pounds, including tools and clothing. Okay? ANSI came out several years back and said, hey, we got bigger guys out there working at height. So now we have harnesses rated at 420 pounds worker weight capacity. Beware, most lanyards and most retractables only have a 310 pound worker weight capacity. Now, we do have 420 rated retractables and lanyards, but you gotta be able to identify it, right? So that's why, that information's on the label, and so that's why labels have to be present and legible, not because they're trying to get you to buy new product all the time, but that information's on that label. So if the label's in good shape, we're gonna start looking at the webbing. Most all the manufacturers use the same types of materials for the webbing. It's usually polyester, maybe a blend of polyester with polypropylene or nylon. And all three of those materials are basically a plastic, right? So we know there are certain things that will affect this webbing, like aggressive chemicals. So let's say you get a chemical splash on here and it sets, it dries. It's probably going to leave some kind of discoloration on the webbing, like a dry, brittle brown spot. You see that discoloration, that's your visual clue that there's something going on. We need to take a closer look at it. Inspect that discoloration. It's probably a dry, brittle, hard spot by now. That's a weak link in the webbing. Technically, by law, for OSHA will follow the manufacturer's recommendations on the inspection process. So whatever the manufacturer says, OSHA takes it as law, right? I am not allowed to have a hole, a cut, a tear greater than 1/16 of an inch. That's pretty small, right? And I've heard rumblings, they may eliminate having any damage on these webbings. If there's anything at all, they may require you to get a new harness at that point. But for the time being, it's 1/16 of an inch. So if you think about that dry, brittle, hard spot on here, if it's greater than 1/16 of an inch, it might be grounds to reject that harness. It depends on how weak it is, but it's likely real brittle right there. If you have a split or a tear at the edge, let's go ahead and take it out of service because you've impacted it. It's probably going to continue to tear, right? Abrasion, you got light abrasion, moderate abrasion, heavy abrasion. When do you take it out of service? And this is your judgment, guys, not mine. So when you're looking at this, I can live with a little light abrasion, a few fuzz balls on them like your favorite t-shirt. But after about 12 years, you can see through the t-shirt, it's got all the fuzz balls. Same thing happens with this webbing. You're rubbing up against concrete and stuff like that. So just be aware. We can tolerate a little light abrasion, but anything more than that, we're going to err on the side of caution and go ahead and take it out of service, okay?
Very important where you store your harness. After you're done, just don't throw it in the game box and allow the game box so tools get thrown on top of it.
Exactly.
Find a place on the job site to hang them up and take care of it.
Right. So, we want to keep this away from those sharp edges. We also want to keep it away from hot surfaces because polyester, it's a plastic, right? And also, I know you're working outdoors in it and you're going to get that UV damage, but you don't want to store them next to the window and let sunlight beat on them all day. See how light yellow this lanyard is? And if you look at it closely, it's kind of fuzzy and puffy. That's UV damage. Over time, that UV damage causes it to expand and gets fuzzy. Probably lost at least 50% of its strength. Okay, you can't ride on the webbing. I failed many harnesses because guys take a magic marker and ride on it. They leave a blank spot on the labels now. If you guys insist on riding on the webbing, you can use a Sharpie marker as long as you get the letter from the manufacturer that gives you approval. That way, if OSHA comes in and says, hey, you can't do that, you can say, I used a Sharpie, here's a letter of approval from the manufacturer. Then you're safe. I've had guys wrap duct tape around the webbing for different reasons, but some of them will write their name on the duct tape so they don't ride on the webbing. The adhesive of the duct tape is 100 times worse than the ink itself, and it will degrade the webbing. Oil, grease, petroleum products, if this gets saturated with oil, it may not happen overnight, for probably a couple, 5-10 days, you're going to notice it starts to get soft. heavy soil, fine particulates, and you add a little oil, so now you got a little abrasion going on, that oil is breaking down the webbing. And if you feel your webbing, you can stretch it a little bit, because it is polyester, right? When it breaks down, it gets soft. You can stretch it a little bit. It's time to replace that harness. So beware of those heavy soil webbing on the harnesses, and check and see the integrity of that webbing. Kind of pull on it, see if it's stretching or not. You can wash these. No power washers, no aggressive chemicals. Basically a drum of water, Dawn dishwashing detergent, or 8 degrees, right? Agitate it, work the grease and grime out, pulls out the soap, take the time to wipe down the metal hardware, but you might get a couple years extra out of your harnesses. I don't see many guys doing that, but there are services out there. Companies will pick up your fall protection gear and take it and clean it and inspect it and stuff like that. So those are the big culprits on the webbing. If you have the older harnesses that don't have these impact indicators, you want to look at these stitch points where two pieces of webbing come together and make sure there's no missing stitches. If there's any missing stitches, you might want to take it to Ray, our competent person on the site, and have them look at it. Technically, I can only have one missing stitch. If there's 2 missing stitches or 2 pop stitches, that's supposed to be grounds for rejected. So our life's hanging in the balance on these. That's why they're very stringent about the inspection process of them. And like I said, a lot of the guys are getting hurt these days. It's from a lack of doing proper inspections a lot of times. Metal hardware, the big culprit here is rust and corrosion. Now, if you see any of the metal hardware bent or warped, that's probably a sign it's been impacted somehow. So anything bent or warped, we're going to automatically take it out of service. When you take it out of service, you need to document the date, the part number, the serial number, and that kind of information to do your due diligence. But as contractors, you guys might be wearing these for 6, 7, 8 hours a day, right? You're going to sweat at it. Well, this webbing collects moisture, and where this webbing comes through the D-ring, if you look at some of your harnesses, you may start to see a little rust build up in the corners. Rust will start out as surface rust. It's smooth, right? I can live with that, but over time it becomes pitted, and then it's abrasive, and it's rubbing against the webbing. We actually start seeing webbing getting some abrasion and fraying and cutting right here, okay? So just beware and look at that every once in a while. The buckles on the torso strap. So again, here's the front of my harness. Upper chest strap or torso strap down to the lower leg strap. There's these buckles. I can see those pretty easily, and I can do an inspection. And I want to make sure there's no corrosion going on. I have found these buckles almost rusted all the way through. Some guys miss these. Some of the manufacturers had wider, thicker webbing, and it was just kind of hidden, so, you know, out of sight, out of mind. But make sure you check any of those metal parts where it's holding the webbing together, and make sure there's no significant rust going on there. If you have the pass-through buckle, inspect those as well, and make sure that they're free of corrosion and nothing bent or damaged. Tongue buckle leg straps, again, corrosion, anything bent or warped. These grommets in the leg straps, they might spin a little bit, but they shouldn't be freewheeling. If it's freewheeling, it's probably time to get it replaced. If you got excessive leg straps, you can't cut the ends of them. There's web keepers on here to tuck them in. You use a rubber band or string to tie them down. No metal wire, because that will start cutting through the webbing. We had a guy they bought 21 brand new DBI harnesses, the big expensive fancy ones. He took a wire crimp and crimped all the D-rings up so the guys could reach them, but he cut through the webbing. So beware of that. Then the other area we want you to look at, see this plastic piece right here? I call it a web keeper because it keeps the webbing crisscrossed over my shoulders. There's a plastic piece right here at the chest strap and the torso straps that allows for some adjustability. And once in a while they get a bad recipe, so to speak, and you get a piece of brittle plastic, it cracks, it has an edge, and it can start cutting on that webbing. So just make sure that those plastic web keepers are not cracked and causing any kind of edge. got the sheet there that'll help you along. And I can also send you sheets for lanyards and retractables for the inspection process if you want.
Maybe, can you talk a little bit about calculating your total length of fall protection?
Yeah.
If you're using a retractable, does that minimize a lot, or?
Yeah, so, you know, our lanyards, we wish they would stop making these. Why? Because this is the most misused, most abused, most dangerous piece of fall protection equipment we have. This is the bungee type lanyard. This will get the forces down to 900 pounds as well. It's going to allow a 6-foot free fall, but it will reduce the force down to 900 pounds. Just like the other one I showed you with the shock absorber, it does the same thing. But if we're going to use a lanyard, you get the right one out. So we got several different types of lanyards. We got leading edge lanyards, like this. This is a leading edge device right here. So it's got a steel cable. So if I go over that rooftop or metal edge, I-beam, I got some steel cable that's going to give me that added protection. And it's got a heavy duty shock pack. But this heavy duty shock pack, it's more robust, it's bigger, but it's got more payout as opposed to a standard lanyard. So we have to know which lanyards we're using, and then we have to know how to calculate the clearance. So on an everyday lanyard, like this is a 6-foot shock absorbing lanyard. You got to account for your height right off the bat. And then you got to add the length of the lanyard in there. So if I'm 6 foot tall and I got a 6-foot lanyard, I'm already at 12 feet, right? And then this shock pack right here, this is just a better visual than that bungee one. But I got the 6-foot lanyard, then I got the shock pack on my everyday shock pack that gets the forces down to 900 pounds of force. That's 4 foot of material in there. So we got to add that to 12. That takes us up to 16 feet already, right? We got to allow for that D-ring slide. Remember, 1.5 foot of D-ring slide. So I add that. That's 17.5 feet now. Then OSHA says we have to have a 2-foot safety factor. So a 6-foot guy with a 6-foot lanyard, you need 19.5 feet of clearance in order not to hit whatever's below you. Did you guys know that? So you see why I'm saying this might be one of the most dangerous pieces of fall protection equipment we have, because guys are not calculating the proper clearance. That's why I say you really want to understand these, read that instruction manual. They have charts in there, visual charts, that show the calculations you need for it. So that's a standard lanyard. Now think about where your tie-off point is. You know where the D-ring is on your harness, right in the middle of the shoulder blades, right? If my anchor point drops below that dorsal D-ring, so say that anchor point's down around my hips, I have to add that additional distance in now. So I could be at 21, 22 feet of clearance. Does that make sense, guys? Anytime you're using a 6-foot lanyard and the anchor point drops below the dorsal D-ring, really what you want, not that lanyard, you want this lanyard. This is an extended free fall lanyard right here. So if you have a greater than 6-foot free fall, you should be using this extended free fall. This will allow for a 12-foot free fall, but it only gets the forces down to 1350. But the iron worker is bringing in that's going to bolt in the next I-beam from the crane. He's going to be standing on that top I-beam, waiting for that next. He's going to use an I-beam anchor. And if he falls, he's going to have twice the fall as anybody else if he's tied off at foot level. So anytime the anchor point drops below the dorsal D-ring of a harness, you need to consider, if you're using a 6-foot lanyard, that extended free fall lanyard. Does everybody get that?
So
Okay, that's really
if we use the yo-yo,
now you use a yo-yo. Now our yo-yos, we're only allowed a 2-foot free fall max. So if you're using a retractable, you don't want that anchor point any more than 2 foot below your dorsal D-ring. On our retractables, I can call this a 6-foot retractable lanyard. You know, our retractables can go up to 180 feet, but this is a personal size. And we have Class A and Class B. So you need to understand if you're using a Class B or if you're using a Class A. So, Class B is like my everyday lanyard. It will reduce the force down to 900 pounds. If you're using this and you fall, the maximum payout after the fall is 54 inches, 4.5 feet. Now, this is a Class B, and it may say deceleration distance of 54 inches. So when I say deceleration distance, I mean the same thing as payout, okay? So maximum payout or deceleration distance on this is 54 inches. So with a retractable, I can really kind of calculate from the ground up how high my anchor needs to be. If I'm 6 foot tall, I got to count for my height at 6 foot. On the Class B, it's a 54-inch maximum payout, so I add that 4.5 feet, that takes me to 10.5 feet. I add my 1.5 D-ring slide, it takes me, what, up to 11.5, 12 foot, and a 2-foot safety factor. But with a Class B retractable, I only need 14 foot of clearance, as opposed to 19.5 feet for a 6-foot lanyard. Now, if you fall with a 6-foot lanyard, you're going to be about 18, 19 feet below the anchor point. You're probably not going anywhere. You got to wait to be rescued. You got to worry about suspended trauma syndrome, right? If I'm using a retractable and I fall, these lock up very quick, just like a seatbelt in a car. If you hit a car head on, you want that seatbelt to lock up quick enough to keep your face from hitting the windshield, right? These lock up every bit as quick. This is the same technology. So, I've done that 220-pound weight and done drops with these. I can barely get 7 to 8, maybe 9 inches of total payout after I do the drop. Now that's not counting how much line you have paid out doing your job, but after the fall, it's only going to allow you to fall a few more inches, and it's going to lock up. And if you're only falling a few inches, you may still be pretty close to where you fell from. You may be able to pull yourself back up to where you came from. That makes sense, guys? So retractables really are a much better solution. You don't have that 6-foot free fall, so you're not generating all that force. And again, these lock up so quickly that you might be able to pull yourself back up to where you came from and not have to worry about rescue, shutting down the job, and suspended trauma and all that stuff. So again, a Class B 54-inch deceleration distance. If I'm using a Class A, these small ones, these are all Class A's. Class A is like that extended free fall lanyard, or that, the extended free fall lanyard, where if I fall, this will only reduce the force of my body down to 1,350 pounds, not 900. So it's a little more force on the body, but we're stopping you quicker. So the maximum payout on a Class A, the deceleration distance is 24 inches. So now, again, I can calculate how high my anchor needs to be. If I'm 6 foot tall, I got to count for my height. I add the 24-inch deceleration distance on a Class A device. And that takes me to 8 foot. My D-ring slide of 1.5 foot takes me to 9.5. My 2-foot safety factor takes me to 11.5 feet. So now with a Class A device, I can work in those clearances a lot lower than 19.5 feet with a 6-foot lanyard or even the 14 feet with a Class B. But this allows you guys to work at a lower clearance. Anything lower than that for a 6-foot guy, you have to revert back to scaffold ladders or a lift of some sort. Does that make sense, guys? All right, we got to inspect these too. The lanyards, you inspect the webbing just like you did on the harnesses. Cuts, tears, burns, abrasions. Inspect those hooks, whether they're snap hooks or carabiners. Make sure both functions work properly. The gate should contact the end of the hook for a secure connection point, right? So, and make sure it's stamped 3,600 pounds. Rather you got a steel wire rope that's 80 foot long or a 6 foot or 11 foot retractable. Let me just share another story. We were doing a 6-foot version, inspecting these on the construction site about 7 years ago. And they asked us to inspect their DBI Nano-Loks. They were 6-foot retractables. Well, you got to pull the webbing all the way out. We found 6 of them. Somebody took a knife and cut 3/4 of the way through. And the guys that were using them, their jaws were hung wide open. They couldn't believe that we found 6 of them and somebody took a knife right at the end and cut 3/4 of the way through. Obviously, it had a disgruntled employee. But the point of the story is those guys were not doing the proper inspection and they missed it. Had they fallen, it was gonna fail. So you gotta pull the webbing or the line all the way out and inspect from end to end. If you're using steel wire rope, if there's any broken wires, you pull the webbing all the way out, have some gloves in your hands, and let it retract back in. If there's any broken wires, if you don't catch it visually, it should catch on the gloves. Technically, you're allowed 5 broken wires. Only 2 per braid. There's 7 braids, 13 individual strands. You're never going to find out which braid those broken wires on. If there's any broken wires, best practice, take it out of service, get a new one until we can have it inspected, recertified, or replaced. That makes sense, guys? Just make sure you pull that line out and inspect the entire length of the line. Make sure it locks up when you pull on it, okay? Check the carabiners. The housing should be in good repair. You can get debris. If there's a hole or a gouge in here, I can get debris up in here and it might affect the locking or braking mechanism in there. And then it's not going to work for you, okay? So no holes or gouges in here. Labels got to be present, legible. Now, I mentioned leading edge a couple times. You know, we've had guys go over I-beams, flat grooves, steel, wood, concrete, and those edges have cut steel cable. If there's any potential for your line to come in contact with any kind of edge, unless it's a big, round, smooth pipe, we should consider everything an edge. Rather it's a 90, a 45, beveled edge. Even a beveled edge can create the cutting action, especially with that pendulum effect. And like I said, we've had steel cable cutting. So we have leading edge devices, okay? And to be approved for leading edge, it has to say leading edge, approved for leading edge. Now, I hate to say there's a new SRL standard that's proposed that's supposed to become effective August of '23. It's not set in stone yet. And if they do that, everything's going to change. But until that changes, we got to talk about Class A and Class B. And Ray, when I find out, I'll let you know. But that leading edge is really important. If there's any edges, you want a steel cable, retractable with a shock absorber in line. Okay? This shock absorber, so, you know, when you fall over an edge, you're going to have 2 points where that load's going to be applied to. It's going to be applied to the body, so the brakes and the gears in here will take that load off the body and reduce it down to about 900 pounds. And then, when you go over that edge, and you have that pendulum effect, you got this shock absorber in line that's going to pay out and take the load off this cable at the edge and prevent it from snapping in half. So you just really got to recognize the hazard. So electricians, you know, we actually have arc flash rated harnesses, lanyards, and SRL. Guardian doesn't at this time, but the product is available. But my point is, we got to recognize our hazards and select the equipment based off the hazard. For example, if there's an edge, I want a leading edge, either lanyard or retractable, preferably a retractable. If there's hot work involved, you know, welding, we have Kevlar harnesses and hot work approved lanyards and SRLs. Same thing for arc flash and then that leading edge. But just recognize those hazards and then select the equipment based off those hazards. That way we have the right equipment. Rack back tie back. You guys might appreciate these. If you haven't already seen these, you ever seen this flat snap hook, the flat top up here, guys? Ray, have you seen this? So this is a wrap back tie back unit. So which means this is basically an anchor point. If I go up in my lip and there's an I-beam there with no D-ring, I can take this pigtail and wrap it around that I-beam, and now I'm tied back off to myself. But this now becomes an anchor point. And all anchor points are rated for a load capacity of 5,000 pounds. So this gate and this entire gate on this hook and the hook itself is rated to hold a load of 5,000 pounds. It's the only one approved for raft back tie bag because it has that 5,000-pound loaded gate. Okay?
The biggest thing, guys, take a look at those, make sure they're rated for 3,600 pounds or 5,000 pounds. Anything less than, you gotta take it out of service.
Right, exactly. Now, we do have personal size leading edge SRLs with the raft back tie bag. So this is a leading edge. You can get this in a single or twin lane, but you do get the versatility of that raft back tie back. So you got the both worlds. You got that added protection with leading edge, and then the versatility of that raft back tie back. All right, how much time we got left?
We're right on mark 4.
Okay, real quick, tool tethering. The reason I'm bringing up tool tethering is because there's a new ANSI standard on tool tethering. There's about 200 and some odd fatalities every year from guys dropping tools in each other. So there was a flood of imported product into the country, and that, lack of a better term, that cheap stuff was failing. So the manufacturers in the U.S. went to ANSI and created an ANSI standard. Well, OSHA found out about it, right? So now OSHA's starting to cite some of the contractors the ANSI standard on tool tethering. So if OSHA adopts it, then that would mean anytime you're working that height, you will also have to tie off your tools. So real quickly, we can tie off cordless drills. Our tape measures, got a little boot here that I can tether it off with. We have cold shrink rubber, kind of like the hot shrink, but it's got a little piece of rubber with D-ring. Just know that this may be coming sometime. A couple of things. If you tether off tools to the body, no more than 6 pounds. Anything more than 6 pounds cause you to lose your balance. You would tether off to the structure.
We've seen this on the jobs.
There's kits available. If you don't know what you need, just hand a kit to one guy. And it's got everything he needs, and it covers multiple trades, iron workers, scaffolding companies, and construction. With that, guys, I hit a lot of information. I went through it pretty quick. Is there any questions on anything? Is it raining out there?
Yeah, it's raining. I don't think we're gonna get the,
Yeah.
Do you guys have corrosive equipment?
what?
Corrosive rated equipment?
resistant, corrosive resistant.
So, all of our anchor points and all of our hardware meets the most current standard for corrosion resistant material. Now that doesn't mean everything's been iodized or coated or anything like that, but we still have issues with some of the corrosion. Now some of the higher end harnesses will have coated hardware to help preserve it a little longer, stuff like that, but we do meet the current standard. So and the new standard is extreme temperatures and corrosion. Yes? How about that bag? So the bag, this is back to your tool tethering. This will hold about 150 pounds. So if you drop it, it shouldn't blow up on you. It's got a zipper. It has D-rings to tie off your tools inside. I got my D-ring here. But this is basically the tools and nuts and bolts up to the working height.
Can the bag no longer be standard?
I haven't heard that, but maybe you have. What are they supposed to be made out of now?
That's just, I'm saying the old style typical ones, we don't own.
This has a reinforced bottom, and it's more like a canvas or some kind of material here.
So you can hang that to
Yeah, you
working
can
up on.
You can hang it on the rail. We also have a little inexpensive winch that you can crank your tools and buckets up. But it fits like on a handrail, guardrail type thing.